Hi folks, we're going to take a look at page 209, number 19. So here we're talking about a satellite that's orbiting the Earth. So I'm going to draw a picture here. So say this is the Earth. Okay, and there's my satellite that's orbiting around the Earth. Okay, and it's in what's called a geostationary orbit, meaning the satellite is always above the same point on the Earth. Okay, so we can answer questions A, B, and D essentially all together. Okay, so question A says, explain how such a satellite could remain over the same point as it orbits the planet. Well, essentially that means that the orbit has to take the exact same time as one rotation about the axis of the Earth. Okay, so since this rotates every 24 hours, okay, the rotation of the revolution of the orbit needs to happen in exactly 24 hours. So they're always kind of along the same line at the same time. Okay, so here orbit takes the same time as one rotation of the Earth. Okay, and of course that then answers part B. It says, well, how long will one of those orbits take, one of those revolutions take? Well, it's going to take 24 hours because that's how long it takes for the Earth to spin about its axis once. Okay, and then part D, they're talking about angular velocity. Well, again, angular velocity is the angle per unit time, and here, well, one rotation corresponds to a turn of 2 pi radians, and one revolution would also correspond to 2 pi radians, and so those have to be the same within 24 hours. So the angular velocities should be exactly the same. Okay, and in part C they ask us to actually determine that angular velocity. Okay, so what's going on here? We have one revolution, okay, which is going to take the same amount of time as one rotation of the Earth. Okay, so that's going to occur in 24 hours. Okay, and what we need to do is turn that into radians per second. So we know to complete one revolution is 2 pi radians. Okay, and 24 hours, now we just have to turn that into seconds since they want the answer in radians per second. Okay, so we got 24 hours times 60 minutes for every hour times 60 seconds for every minute. Okay, and since here this is an application problem, we can approximate the answer. Okay, so let's see what we have here. We've got 2 times pi, okay, and that's being divided by 24 times 60 times 60. Again, please make sure you're using brackets here in the denominator. And what do we have? We have 0.00007, let's say, let's keep 3 of them, 727 radians per second. Okay, so again, that's quite a small number, but you have to think there's 24 times 60 times 60 seconds in one day. Okay, so just to recap, we gave our explanation as to why the orbit had to take the same amount of time as one rotation around the Earth, and then in terms of actually calculating the angular velocity, we start off with the information that we figured out, that it has to complete one revolution in 24 hours, and then it's just about changing the units. So revolutions into radians, hours into seconds. Okay, that's it for this one.